It's very difficult to follow the light-up base, which was awesome with date time, but I'm gonna try. I'm Maggie Johnson-Pint. I work for Microsoft. I also collaborate with TC39. If you're like, didn't you have the same last name as that guy? It was my husband who talked about Stack Overflow earlier today, so like if you wanted to click it together, now you know. But anyways, I'm here to talk to you a little bit about programming in the fourth dimension, time, right? Like physicists, it's always the fourth dimension in their equations. So day in the life of Maggie, especially like when I'm somewhere like here. Hey, Maggie, can I have a moment? I do maintain that library with a few other people. Did you know about that falsehoods programmers believe about time video, or that place where midnight doesn't exist? I think it's in South America somewhere. Or that leap year 2012 bricked every Zune for an entire day? Did you know we might colonize Mars soon? Do you know how we're going to keep time there? Because I think that's really important right now at this instant. There's some country somewhere where there's a whole day missing to a time zone change. Have we accounted for that in all of our models? There's a gap between the Julian and Gregorian calendar, and we need historical accuracy. And I'm like, yes, I know all of those things. I can actually tell you about 100 other corner cases in date time. What I do want to say, though, is I think as programmers, we sort of think about date and time as fun trivia, and then we go, not doing it, not learning it. Too hard, ridiculous. But here's the thing. Getting this stuff right, it matters a lot. Date and time is a primary application in computing. People rely on code to give them accurate date and time. And it's really critical to people getting places on time, paychecks having the right amount of money, coordinating international conference calls, like world peace, maybe, like what, medical device behavior. I was talking to Jana, who spoke yesterday. She's a person with diabetes, about the work that she's done in date time in insulin pumps, and it's like, that is serious. Like, we've got to get that right. And you know, the other thing that I think is really important to keep in mind with date time is that it's really easy to say, well, that doesn't matter. But when you say, well, it doesn't matter that I can't support time in Nepal with its plus 45 offset, plus 545 offset, you're really saying the people in Nepal don't deserve an accurate time. Ultimately, daytime programming errors disproportionately affect people who live in time zones that we don't live in, who speak languages other than English. A lot of our formats default to English. I love giving these talks in Europe because people are like, we know. And so it actually, hourly wage workers, they're going to be affected. If we don't get DST changes correctly, they're going to lose an hour of compensation. So it disproportionately affects actually more marginalized people. So it's just something to keep in mind. So here, those of us who write JavaScript have been using the worst solution possible. So date has a lot of problems. And I'm going to go kind of quickly here through some of those problems. Here's a simple one. Look at me trying to make December 3rd and getting January 3rd. Why? The months index from 0. Why? Programmers. This one is probably one of the worst problems that we have with the Moment.js library because it papers over the problem and kind of exacerbates it in a worse way. But dates are mutable. Now, you typically don't want a value type to mutate, if that makes sense. And you get lots of transient code errors like this one where you see I've created an add days function. Because we don't have an add days, you set the date and then you add 3, which is also terrible. And then I'm returning the date back. And when I invoke it like I did down there, you see me passing in December 3rd, trying to add 3 days, and then getting both dates turned into December 5th because of that mutability aspect, which is not good. Time zone gaps. I can print out my local time. I can print out UTC. If I want to understand, next week I have to meet with the Bay Area team and I'm in France, what's 9 o'clock Bay Area time here in Paris? We ain't got nothing for that. No date-only representation. This one's a little more complex, but birth dates are a common case for this. So, say I want to create Mr. Sulu's birthday. I pass in 2014-9/12, which is Mr. Sulu's birthday. And here you see me calling toDateString, and it gives me back September 11th. There's two things going on here. One, we don't have a way to represent just a date. And two, we have inexplicable parsing behavior. What's going on is that it's interpreting that first string, 2014-912, as UTC. And then if you pass it in with a time of 0, it interprets that as local time. So you see the two different resultant outputs on this slide. This is in conflict with the ISO 8601 standard for date time. Those should both be interpreted as local time according to that standard. But this is the way in which we live. Dan, who's talking after this, can tell you a ton about it, but I don't think he's going to during his talk, but he knows the most about this. By the way, Mr. Sulu is my dog. If you all were like, I think George Takei was born long before 2014. This is my dog, Mr. Sulu. The biggest problem really that we have with date and time in JavaScript is that it's what you might call an incomplete domain model. So I don't know how many people here are like into the domain-driven design. I'm a big fan. But a domain model is a system of abstractions that describes selected aspects of a sphere of knowledge, influence, or activity. Very abstract. But every time that you are working in programming, and you go and you make your model classes for like user and then maybe transaction, you're making a domain model. You're building objects that describe the problem domain that you're working in. And I'm working currently on a proposal with TC39 to get us a complete domain model for date and time at the language level. So Temporal will be a new global, like date or like math. It'll be a new global, and you'll chain off of that to create new objects. So we're introducing a whole bunch of new types because date is a huge domain. And I've got a lot of code on these slides, but I have to go quickly. I will post them online because there's a lot of types to get through. So first of all, cancel date because it sucks. And separate the concept of absolute time. So assuming that we have a contiguous global timeline, that time always goes forward, it never goes backward, and it never has breaks, which is generally true, then we should be able to reference a point on that timeline and say, everyone in the world agrees that we were at that point. And that's actually what UTC is, right? But in Temporal, what we call this is absolute time. Conceptually, this is absolute time. And scenarios for absolute time are like log data. I want to know exactly when this event happened. Any kind of point-in-time events are absolute scenarios. And so in the new API, what you're going to do is when you have an absolute scenario, point-in-time scenario, you're going to create a new absolute. Little thing I'll notice that we snuck in here, there's a big integer being passed to that, which makes our precision greater. Right now, date only supports milliseconds, but we're able to go out to nanosecond precision in the new proposal. You can also parse an absolute from an ISO 8601 string, and it will parse the way the standard says and not any other way, which is great. But besides point on the global timeline, we also have the concept of local date and time, like where we are now. And a lot of times when people talk about local date and time, it's a perspective of time, and without any additional information, you don't actually know where it is on the global timeline, right? When we say it's 4 o'clock, you gotta give me so much more information to know what that 4 o'clock really is. Things to know about local time, it's actually non-contiguous. Because of DST transitions, you can have 2 instances of a local time. You know, when we do the fallback thing, you can also have gaps in that timeline where, because we sprang forward, there's a series of times that don't exist. And we have to actually write specific code to make sure that when we try to convert to the global timeline, we handle those corner cases. So local date time scenarios. You have a local date time object. Biggest one is non-connected devices that later upload. So insulin pumps I brought up, Jana was teaching me all about this, it's amazing. But insulin pumps, watches that later connect to the internet, things like Fitbits, anything that's connecting later, you're setting a local time on that, and then later on you're uploading that local time and associating it with other data. So using date time, pretty simple. You come in and you say temporal.datetime, and you can parse it out of an ISO 8601 string. And this has no connection to the global timeline. It is simply a floating date and time. But obviously, we might want to connect these two things together. So the next thing that comes into play is temporal.timezone. And this is an object that describes that relationship between local time and that global absolute timeline. So you can actually represent 3 things that are not all exactly time zones in temporal time zone. One is you can make a time zone that is UTC, which is time zone of the global timeline. Another is you can make a fixed offset time zone, so that's like +1. Be very careful, a fixed offset is not the same thing as a time zone. If you take a fixed offset date time, and then you say, I want to know what time it will be 72 hours from now, because of DST changes, it may not be a straight 72-hour rotation. The offset may have shifted. And then the final thing that we support is an IANA time zone. And that's, the IANA time zone database, for those who aren't familiar, is like the master database of time and how it works everywhere. It includes not only information about when we do things like DST changes and what our offsets are all over the world, but it also includes historical information going back to basically the start of the railroads. So it gives us a lot of information over time of what we have chosen to have the offsets be in different places. When combined with an absolute or a date time, a time zone gives you like a complete picture of everything that's happening here. It gives you the local time, it gives you the point on the global timeline. So that lets us answer some really good questions, like at what point in time did the insulin pump run at? So this is an important question to answer for your doctor, right? Like you have an offline insulin pump, it has a time, you upload those times to a computer, you were traveling, your doctor wants to understand for your benefit, when did your insulin pump go off? This seems like something that's really important to get right, doesn't it? So you provide the time zone that you were in, you see providing the time zone that you're in, the local device, the string that came from the local device of the date time. You get a date time from the local device, the time zone, and then you say time zone dot get absolute for, so get me the point on the global timeline, and what you get back here is that point in global time. So I'm hoping you're starting to see that this API brings many different concepts together. These objects individually aren't that powerful, but when they're working together, they give us a very complete description of date and time. I hit back. So, breaking apart local date and time, really common scenario is just a date. So there's a date without a time, and it presents time assumption errors that cause unexpected behavior. So this is really common for dates of birth, like employment data hires, holidays, report groupings where you want to say for the business day of. Anywhere where, like your birthday, like I was born in Minneapolis, but if I'm here in Paris on my birthday, I'm not gonna like wait until Minneapolis clicks over to my birthday. I'm gonna be like, it's July 27th, it's my birthday, wherever I am. Any other July 27th, like birthday paradox? I can't even see you, I'm sorry. If you share that birthday, I was a math major, I love the birthday paradox. But so, this really cleans up Mr. Sulu's birthday. I can parse just a date, and then when I call it out to toString, I get just date information out. I can also, how many people are storing just date information in a database somewhere with a whole bunch of zeros appended because there was no good way to store just a date? Like someone's doing that, right? And then you get these funky bugs where you reparse it and it's a couple hours off because something shifted it to local time even though it wasn't supposed to be local time and actually didn't have any time at all. It would be better if you parse that into just a date, and then what'll happen is your code will never shift because nothing can have a weird side effect behavior. And if someone, say, tries to get your hours from just a date, they're gonna get undefined. So they're not gonna make a programming error of assuming later on that that time was actually a time. You're telling them very clearly, only dates here. So on that note, we also have scenarios where there's only a time, right? Time without a date, again, it prevents date assumption errors. Probably somewhere you're storing like 1900, 1037 for some purpose. Great for recurring meeting scheduling, data from non-connected clocks. So what we can see here is, say you want to do a recurring meeting. Well, because of DST changes, you should never store recurring meetings in UTC because they'll shift around on you. You need to store them in local time. And here what we can see is I want to have a meeting twice in Paris, once on January 1st and once on April 1st. And we can see that I'm combining that 10 a.m. with the time zone and the date. And the first instance of my meeting comes out at 9 o'clock UTC, and the second comes out at 8 o'clock UTC. So it lets us cleanly express that 10 a.m. in local time has two different actual UTC values. Durations, I'll go really fast, used to express a length of time, useful as a format in and of itself, useful to add and subtract. So exactly how old is my dog, Mr. Sulu? I can come out here and I can have that returned as a duration. So you see down there a period of 5 years, 2 months, 3 weeks, and 4 days. Very handy construct. Other good stuff, so much content, so little time. This is a huge proposal. Year, month, and month day. Year, month is good for things like historical time, like in December of 76. I was doing historical time frames like that. Month day is really good for holidays or birthdays. Mr. Sulu's birthday is September 12th. New Year's Day is January 1st. Alternate calendar systems. This is a huge aspect of this proposal. We're looking at getting in the Hebrew, Hijari, Japanese, the many other calendars supported directly in the language, which again, when we talk about inclusivity and JavaScript serves everybody is really awesome. If you do regularly use an alternate calendar system, your feedback would actually be extremely helpful right now. If you could go to that GitHub issue and tell us how and in what ways, we would love it. So how do we get this done? Like, this is a lot of stuff. I hope it looks like hey, that would help me in my day-to-day job to program better. Temporal's currently at stage 2 of that 4-stage process we described. We're working it towards stage 3. The 2 to 3 jump is usually one of the longest jumps. It's actually been in stage 2 for over a year now, and I've been working on this for 3 years. Until stage 3, the APIs are incredibly unstable, but we do have a polyfill out there in the repo that we'd love for you to try. Good news. Not everything is like this in TC39, but I would say that at a top level, everybody wants this proposal. There's nobody who's like, don't put better dates in this language. So that's good. That means we can probably move forward pretty well. This is a great space for community contributions and a space where genuinely, especially if you have lived with different calendar systems in your day-to-day life, we could really use your feedback. So feel free to hop on that proposal, check out the polyfill, and come in and contribute. We're not kidding. We need it. We don't have the expertise. I do want to thank a few incredible people. This proposal, as you can see, the API surface is huge. I'm talking really, really quickly, it does this and this and this and this. It's not just Maggie who does this. In fact, for the last year, it's been Philip Dunkel from Bloomberg who's done substantially more work than me. My husband, Matt, Dan Ehrenberg, Richard Gibson, Shane Carr, Brian Turleson, Ujwal Sharma, MS Tujer, who does not like he just uses GitHub handle, all have invested so much time in this. So thank you to all of those amazing people for helping to move this forward. And again, I'm Maggie Johnson-Pint. You can hit me up on Twitter. And I hope you're feeling confident that someday you're gonna have accurate date and time computations.